So in our previous video, we're able to look at some of one of the two best way to actually handle that or the missing values in this of the Sklearn by making use of this simple inputer and this of the KN inputer. So like I said in today's video, what we are basically going to do is actually to learn how to actually scale our data down, because when we look at this, we can see that our salary tend to be greater, more greater, you can say much greater than this of our age and this of our experience, and most of the time this can be a really bad thing for our model. So you can see up to now we have not actually put any model, we have not actually trained any model to actually make any predictive output. So I just want us to actually have a background knowledge on how we can actually handle missing data, actually structure our data really well before we can actually feed it into any machine learning model. Like I said initially that and I think that should be our chapter 3 of our video when I explain the three key concepts behind that of the machine learning. The first is actually that of the data side, because data side can be really stressful. This is where you'll be handling all this kind of pre-processing, scaling, normalization. I can say a whole lot of feature engineering, a whole lot of things that comes with this of the data side. That's why I rated almost 60% of the stress you are going to pass through when you're doing any machine learning. Can see any machine learning tasks that you are given. So remember that this is what we had earlier when we actually make use of this of the KN inputer to actually, and that of the same inputer to actually handle missing value, and this was the output that we actually get. So this video, like I said, what we are basically going to do is actually to scale down our data, because right now our data can is really huge. So remember that this is our initial data frame, which is this guy up here, and then after that let me get rid of this so we know what we are doing. So the next we have here is this of the where we actually initialize that of the KN inputer, giving it the parameter that I need, and then the output where we did that of the model.fit_transform, and then this is the new data frame we have. So what we are going to do, we are just going to change the value of this. I don't want us to make things more complex the way it already is. So before we can make use of that of the StandardScaler, min-max scaler, and that of the robust scaler, because that is basically what we are going to handle in this video. But that of the StandardScaler, the min-max scaler, and the robust scaler, these three guys are basically three ways we can actually scale our data down. So some machine learning algorithm will not tend to favor some features over some because of how large their data is. Just imagine, let's say in a particular scenario whereby maybe a salary increase in salary actually maybe directly refers to that of the increase in maybe one word or other refer back to that of the increase in experience, because that actually tends to make sense. So the higher your experience, when look at it, I think it actually directly refer back to that of the increase in your salary. I see that, and then this salary is a huge value, and I can say when I mean huge value, import that of the standard scaler and that of the robust scaler and that of the min-max scaler is basically simple. So we can say from our what, remember they are all part of Sklearn and pre-processing. So we can say from our Sklearn dot what, pre-processing, we want to import our what, that of the standard scaler. So that is the standard. This is it, standard scaler. We also want to import our min-max scaler, and also want to actually import that of the robust scaler. So we're basically going to make use of these three guys to actually scale our data a little bit. Remember, like this of our salary, when we look at it, is a really huge value, because with this our model can tend to favor this of our salary future over this of the experience or that of the age. It will just neglect the way it will weigh them less, because you look at, since these values are this salary as a high value. So to actually make use of this of the standard scaler, how standard scaler actually works is, let me open my WordPad. Let me open this my word part. So I'm going to make use of this word part to actually explain how these each of them work. The standard scaler, how standard scaler actually works, that is find the mean of each of the values. When you find the mean of each of the values, and then it's going to find the standard deviation. So each of the values is going to be minus by that of the mean, and it's going to be divided by that of the standard deviation. So this is what I mean. This is the formula. When you get your z is equals to, this is your x minus what? Your mean. Let me just put this guy like this, and then divided by what? Your S T D. This is how the standard scaler actually works. This is how it scales the values, each of the values down. So this is the each of the value, which is the x. Let's say in our case, when we look at this, each of our value that we currently have is this 25, 27, 5,000, a whole, so on and so forth. So these are each of the value that is going to have. So before that, it's going to find this of the mean, and this is actually what that of the fit. Actually, when it fits, it's going to compute all this guy. And then the standard deviation, know what standard deviation is basically about, how spread each of this our data is. That is just basically what standard deviation is. So let's just actually get rid of it. Remember that let's actually set some values here. Maybe we can set this to maybe something like 20, maybe let's set this 31, like what was actually predicted here. And then this was actually for this was actually 60. So actually set this to 60. That is 1, 2, 3, and then let's actually say the maybe something like 3.5, like how we actually got down here. So we have to actually feed the values have to be actually properly handle for that of those of that of the non-values, non-values. So with this, we can actually implement that of the standard scaler. Let's actually say that of the standard scaler here. Standard scaler, simple as that. So we can then standard scaler. We are going to do what? Fit. We are going to model the fit underscore transfer. Remember that this model is a variable that holds of the standard scalar class that we have here. So we are going to learn the parameters on how our data is being structured, and then we are going to transform and make use of it, and then we are going to print it out here with the colon, so we can see how it actually was actually taking effect. And then we're actually going to refer back to this of our formula that we actually explained earlier. You can see that this is the original data frame that we have. This is the computed data frame, second data frame, or the new data frame. You can see that the age, everything has been scaled down. You can see this of the salary. Before this was 50,000, but now we're looking at minus 1.57841. You can see that everything now has been scaled down. Pretty much. So some machine learning algorithms of the z is signify the output, and then the x is each of the value, and then minus u, which is this of the mean and standard deviation. So automatically it's going to get the mean of this of the age and the standard deviation, how they are spread apart. So it's going to be 25 minus the mean divided by that of the standard deviation. That's where we got this new value of minus 1.21. So you can see that each of the values are scaled down to a particular value. You can see that maximum here I can see is 1.54. So machine learning algorithm can easily understand that each features is not bigger than one of the other features, so it can actually learn from each of them. So the next one we are going to learn how to use is this of the min-max scaler. How this min-max scaler actually works is to scale our data from that of range of 0 to that of 1. So the lowest get that of the 0, and the maximum gets that of the 1. So most of the time this min-max scaler is not actually being used really much, but we are still going to see how you can actually use that. Let me just copy this, let me just paste it here. So it's basically going to be similar type of stuff that we did, which is actually our original data frame. This is the min-max scaler, where we set the min-max class, and then we fit into our data, and then we created a new data frame, giving it the column of the previous, which is this of our df variable, the columns, and then we printed the result as output. As we can see the difference between this of the standard scaler and this of the min max scaler, you can see that the lowest get out of the zero. When we look at it, this is actually 25 and the maximum was 40, you get this one. So that just basically how standard scaler actually was. You can see the lowest was 5,000, the maximum was 62,000. 62,000 got 1 and then the lowest got 0. You can see other ones tend to get the you can see ascending other values on them. So and then we can also see this of experience. The highest was this 4 and then it got 1, followed by this. The lowest was this 1.0, it got out of the 0. So those are basically min max scale actually does. It just from what it actually does from that of the 0 is going to be for that of the mean, the minimum value, and that of the 1 is going to be for that of the max. Simple as ABCD. So this guy doesn't really need much explanation and need. So the next one is actually that of the robot scaler. The way this robot scaler actually works can be similar to that of the standard scaler, but it can be a little bit difference in some kind of scenario. Okay, let's actually look at how to apply this robot scaler. There's no really big difference. Just apply the robot scaler here, which is I copied it, Ctrl V to paste it. So let's look at how this robot scaler works. Let me go back a little bit. The way this robot scaler actually works, it works in a similar way like that of the standard scaler. I actually make use of this of our x, which is each of the values, and then we are going to minus it by that of the mean, and then we are going to divide it by that of the Q3 minus what? Our Q1. What is this Q3 and what is this Q? Look at this Q3. This Q3 is looking at that of the 75, I can say, percentile. Let me actually make this, and this is actually the 25 percentile of the data. Everything is going to be calculated automatically. The main ideology here is all your set of data. What is it actually going to your colon? Maybe this age colon here, which is this age colon here down here, which is 25, 27, 31, 35. What is it going to? What is the 75 percentile or the 25 percentile? Initially, what is that basically going to do is to sort them in the orderly way. When it sort them in the orderly way, it's going to find out of the 25 percentile and that of the 75 percentile. I explained this really well, this 75 and 25 percentile in our pandas tutorial, in that of the make use of pandas for data analysis. I explained this percentile really well. So in case if you are still confused, be sure to check it out. So this is just basically the formula that this robot scaler actually make use of to actually scale our data down. So some machine learning models can actually understand the data and learn from that. There are something models like that of the logistic regression. Logistic regression tend to need your data to be scaled down. If it doesn't scale, if you don't get your data scaled down, it might end up treating some features more important compared to the other ones. So this is the main advantage of this of scaling, and then at times scaling also help you to understand the data really well. So some data can be going off and some be doing different stuff. Remember that it's not a must. You must have to put the entire can say scale the entire data. You might start to pick a particular column of your choice. In case if you want to only scale that of the age, you can just put your age here, which is age. You can just put your age here. But in our case, just wanted to sort everything down. It's a good idea if you sort everything down. You know that okay, all your data have been sorted to this particular extent. So remember that this is the formula that this robot scaler to, which is x, each of the value minus this of the mean. Remember that this is the mean. This is of the mean total number divided by that. So each of the numbers, addition of each of the numbers divided by that of the total number. Or amount of number that actually appear in a set of elements. So let's actually see example of this robust scalar. Remember, I've actually applied this robust scalar. The dot fit is going to learn from our data, and then transform is going to make use of the parameter that's actually learned from our data, and then we're going to output it by actually turning it back to our data frame, so it will be easier for us to actually visualize them. So let me actually run this for us to actually see example of this. So when we look at this, the output that we get from this of our robust scalar, I can see that I'll get this minus 0.750, and they will get this 0.0000. Why do you even get this guy? See, wondering why, which is that of the root 2, but that is just basically how robust scalar actually works. So there I can see that the output tends to be a little bit similar to that of the standard scalars, because the formula that they both use tend to almost be the similar things. So let's actually go back and look at some of the formula. I say the output of that of the scalar. Okay, so this is the output of the standard scalar here, and this is the output of the robust scalar. Remember that the formula tend to be a little bit similar. So let's look at this last element here, which is 1.125, but now when you come to our standard scalar, 1.548 something. So when we also look at this 0 that we actually got in this of the robust scalar, in that of the root 2, and they were having minus 0.2, 0.27, and when you look at it, you can see that the values of that of the standard scalar was actually is a little bit greater than that of the output of that of the robust scalar. Remember that the scaling, each of the scaling you want to actually make use of, you need to actually know the reason why you're actually scaling it. So you can't just wake up and apply them, because there's just so many scaling, I can say scaling formulas out there for you to make use of. I can say scaling can see libraries there. There's actually external libraries you can actually install for your scaling. There are a whole lot of them. Each of them has their own advantages and drawbacks on each of them. So before scaling, you used to actually know the key reason why you're actually scaling, because if you don't know, that's actually not a good idea. So scaling it is actually a good idea. Like in this of our case, if you want all your data to be in this of the range of experience, that the maximum should not be exceed more than 4, you can actually do that for every element, and then you can actually say, let's say you want to use that of the standard scale, you can actually set other parameter that will increase your scaling, but it won't exceed 4. So all these things just depend on your choice and the reason why you want to actually scale your data. But scaling your data, like I said, the main importance is actually to get more insight of your data. Another advantage is also help your models, some machine learning models, so like all these weak machine learning models, to actually learn more on your data to give you more accuracy score, and also predict your models, predict your data really well. And also one of the drawbacks of all this scaling, can see all these scaling classes, this of the scaling, that they can be quite slow to actually scale your data, which can actually add some complexity to your data. And if you don't really scale well, if you make a mistake, you can bias your model, you can make your models to actually perform even worse than what it was actually performing for you earlier. So this is actually one of the advantages and disadvantages of scaling. So before you scale, or rather the best things for you to do is, anytime you scale, use the model to predict, and then check your output. Is your model actually performing really well? Is your model underperforming? Is your model over confidence? So all these things were what we were. Is there anything you can do to actually increase the accuracy of your model? Is there any encoding that you can actually encode to make your model more robust, to actually understand more of your data? Because everything relies on how well prepared your data is. If your data is not fully prepared, everything is going to go up in smoke. No model out there is going to actually learn from noisy, you can say extremely noisy data, unless some kind of big models out there can try their best, but when you structure your data really well, they tend to learn more and understand your data really more. So all these things, on all these steps on how you can actually increase your model really more. So we're going to talk all these guys in the next chapter or this session of machine learning by making use of Sklearn. So I'll be happy to see you in the next video.